Hello everyone. I've been working on a permanent housing development after an earthquake scenario using CLT in Istanbul. Istanbul is the biggest city in Turkey, housing 16 million people. It is located at 41 north and 29 east between the continents of Europe and Asia. There are different classifications due to Istanbul's dynamic nature. Köppen climate classification presents 3 climate types for Istanbul with warm to hot, moderate to dry summers and cool to cold, wet winters. The primary focus will revolve around the cold period caused by the low air temperature and the limited amount of solar radiation. Catching the sun is key to achieve comfort levels during the cold period. Istanbul is considered to be in the first-degree earthquake zone. Scientists are expecting a strong earthquake in Istanbul, bigger than magnitude of 7, within 10 years. Unfortunately, the destiny of a country depends on an earthquake right now, which is why fast construction will be a key aspect. Earthquakes are already causing a huge environmental impact by releasing CO2. That's why materials like CLT should be preferred for low environmental impact during rebuild. Turkey has a great local resources to build earthquake-resistant structures. Timber is mainly supplied from the north of Turkey. Kastamonu is expected to be the country's heart for CLT, where it's 500 kilometers to Istanbul. 10-story building made of cross-laminated timber passed the tests on one of the world's largest earthquake simulator at the University of California, San Diego this year. When we look at the development of Istanbul, timber used to be the most preferred material due to earthquake resistance. The modern housing complexes in Istanbul, known as TOKİ buildings, feature deep structures without regarding orientation. A key element that characterizes the essence of Turkish house is the sofa. It acts as a communal gathering area for residents and connection between individual rooms. 3 and 4 unit order sofa layouts can be preferred for climatic conditions because of compactness. The balcony serves to enlarge the living space and range of activities possible in a house. In many old Istanbul apartment houses, the balcony is partly recessed to provide for both sunshine and shelter or shade. Another local element is bay windows, which offer advantages such as privacy, natural light, views, and ventilation. Selected site is located near the Bosphorus. It is very close to the weather station that I use in my simulations. Site has great views to the sea and is surrounded by a generous vegetation. Area is mostly retail. Buildings inside area range from 3 to 10 stories. All of them are uncared and are not prepared for the upcoming earthquake. Rest is used as car parking. Currently, site is mostly used as a car park. An overground bridge is passing by next to the site. Landscape area is chosen to be an emergency area. After setbacks, 1900 square meter is conceived. 2 phases can be held due to the expected intensity in emergency area. Phase 2 can be used as services and storage for both emergency shelters and new housing developments. Then it can be turned into another housing project. Scientific studies assert that shown area is expected to float during the first 2 hours. In order to protect CLT and for structural reasons, a concrete base is suggested. That's why topography should be modified for the CLT structure to sit 3 meters higher than flood risk boundary. One of the reasons to choose this site is sea logistics. Should be benefited from after an earthquake to transfer construction materials. It is advantageous to start a rebuild from coasts because of the rubbles in the surrounding roads. Site resembles of a diamond. Massing study starts with 7-story high diamond geometry, which is shorter than surrounding buildings. Due to increased crime rates after earthquakes, a traditional courtyard is preferred to create secure outdoor areas. This allows all units to face southwest and southeast to get more solar radiation. Simulation results show that the south block should not be more than 4-story high. With this information, first, the whole block is carved regarding the sun orientation, and then created terraces for maximizing the solar exposure. Test 3 shows solar radiation is even hitting the ground floor inside the courtyard in an average winter day. Overshadowing analysis are held together with solar radiation studies. Test 2 shows that opening up the corner reduces overshadowing of the courtyard and units, but upper block is shifted towards one edge, not to block views. A study in MIT suggests that using Nuki joints in CLT construction helps reduce the embodied carbon in buildings. Nuki joints are a common method in Japan and other Asian countries used to connect wooden posts and beams. A basic principle involves penetrating one element through another without using any metal connections. Triangles are proven to be the best geometry for carrying the lateral loads in an earthquake. Structure is preferred to be exoskeleton due to the durability for the future earthquakes. Personally speaking, from a psychological point of view, a visible structure on a building after an earthquake is also reassuring. This module is designed for easy assembly. Slabs are placed on the beams, which allow CLT spans up to 8 meters. As this is a permanent housing project, balconies and bay windows, which are traditional elements in Turkish residential buildings, are introduced into the module. Different types of balconies and bay windows are explored with various openings and sizes. For scale, the person is 190 meters tall. Both-sided openings can allow a space as same as traditional square bay window when opened. Triangular bay windows are expected to behave better than square bay windows because they have less exposed surfaces. Facade boundary can be doubled by separating the balcony from interior space and turn this into a winter garden. Household type study demonstrates that after 1999 Istanbul earthquake, house sharing typology and families with and without children were in high demand. House sharing typologies are considered and can be linked with sofa typology. 3 to 4 people sharing one common area can be promoted in post-earthquake scenario. The housing project offers 4 different types of layout for different users. The units are offered are turnkey units with the objective of allowing users to move immediately. This is achieved by introducing movable plugins, which are going to be chosen by the user before moving in. Plugins offer flexible spaces for sleeping, storing, dining, studying, and exercising. Many activities should be doable in the modules because after earthquake, people are expected to stay at home more and work from home. The primary core is situated in the north to minimize the exposure to direct sunlight and radiation. Secondary cores are strategically positioned in areas where overshadowing is most pronounced. Entrances are recessed to generate sheltered spaces, providing protection during the inclement weather conditions. Shared pockets have been established in flats intended for house sharing, addressing the issue of obscured or unclear views. The corridors remain open to the external environment as simulations have not yielded any substantial change when closed. Commencing with winter, tests initiate by exploring scenarios where the module is constructed using concrete with government U values. Heating demand achieved as 29 kilowatt hour per square meter. And then the module turns into CLT. CLT has more fluctuations when solar radiation hits due to lack of thermal mass. Therefore, the recycled concrete panels are introduced to stabilize the indoor temperature, especially for summer. When winter garden is added, it performs slightly worse, contrary of my expectations. It probably acts as another layer of solar resistance in front of thermal line of the module. Continuing with summer week. This graph is showing how concrete is performing in summer. Lack of thermal mass increases the fluctuations again when we turn into CLT. And then despite integrating even more additional thermal mass on both ceiling and floor, no big improvement is observed after 8 centimeters of concrete, leading to overheating issues. Winter garden addition also provides shade in summer. Consequently, the recommendation of exterior blinds is put forth as a potential solution. Cooling demand is decreased to 1 kilowatt hour per square meter. The selection of the final materials were informed by the simulations carried out. Based on the simulations, these are the best combination for thermal performance. 2 scenarios are tested with movable plugins in units. UDI shows that window areas have high illuminance level, which are uncomfortable. More than 50% daylight autonomy is achieved at sleeping area, even when the plugins are moved. The scenario is suggested at summer when there is high illuminance levels. All plugins are closed and study plugins still achieving more than 200 lux. This leads into a spacious space in summer and more usable area. But to reduce the luminance levels around window, exterior blinds are used. Because there is less illuminance level in winter, study plugins are moved towards where illuminance levels are highest. Area where it's getting the most sun hours in courtyard in a year. Courtyard zones are determined according to the sun hours study. Playground for kids are placed where it's getting the most sun hours in summer. Where it's getting the most sun during the year is for cultivation. And trees are located where sun can reach in the courtyard. Roof deck for occupants is where it's closest to views. Without any shading, in a typical summer day, 31 degrees is felt on a rooftop. Timber slats are not preferred not to block the views of the units. Instead, using canopies can reduce the felt temperature into 25 degrees. As mentioned, shared balconies provide better angles for views. Clear stories also allow cross ventilation in units. This is the module for house sharers. All windows are opened and exterior blinds can be used at the same time in summer in working mode. Clear stories located on doors allow cross ventilation. Working mode in winter, separation between 2 sharers help to reduce the volume in winter for a warmer indoor environment. This is the dining mode, dress mode, sleep mode. Thank you for listening.
Thank you.
Mm-hmm.
Hi guys, so my dissertation topic is adaptive reuse of slum rehabilitation buildings in Mumbai. So slum typology is an informal settlement where people across the country kind of migrate into Mumbai, since Mumbai is like the financial capital of India. What does happen is that these informal settlements kind of create issues within the city, which is why the government created a body called the Slum Rehabilitation Authority to kind of relocate these slums and formalize their housing. What the government basically did was these slum buildings are poorly designed. Slum buildings show issues with daylight and ventilation, and due to these environmental issues, a lot of tuberculosis cases have been found within these buildings. This was mainly due to like the lack of openable windows within the building. Coming to my research question, since there are issues with the environmental qualities of the building, the users tend to kind of move out of the space, which is why the SRA buildings need to be designed better. The question was, what is the maximum density that these buildings can be designed without losing the social and environmental qualities needed for health and well-being? Coming to like the site, so there are various sites in Mumbai. The site that I picked is the HDIL Kurla SRA building in Mumbai. It has 48 existing buildings on site. It's a mere 4-building super block replicated 12 times on the site. Currently, all 48 buildings are empty. All 12,000 homes on site have no occupants. Most of the site buildings are either unfinished buildings. There are waste kind of dumped in between buildings and into the buildings currently. And in 2012, since the buildings were misused, they were sheltered around so that people cannot enter inside the building. The existing kind of layout is a very typical layout where 8 flats are kind of replicated, mirrored, and the same layout continues thrice to form one building layout. The peculiar part is the red highlighted area in between are like the void shafts that are existing right now, which are used just for services. The existing window to wall ratio of the units are 30% for both orientations. Coming to like a brief user group, each flat is usually used by like a family of 4, where the men usually work and the women either take care of the household or are like house helps. These families are lower income group. What the SRA kind of fails to design for is that the informal fabric of the slum is kind of missed out on, where the photo depicts how the circulation spaces of like the SRAs are built. Slums usually have a lot of interactions that happen on the street, which kind of misses out on the SRA typology. Coming to the climate of Mumbai, it's fairly comfortable round the year compared to slight peaks during the summer and the winter months having low temperatures at night. The prominent wind direction across the year is from west and southwest. So to kind of improve on the current building design, I kind of generated a methodology where 2 steps were kind of looked at: the urban scale and the building level, being permanence and the flexibility within the units. Coming to like the first step, which is the urban study, which I termed it as removal of mass. So I looked at first the existing conditions of the building. The urban ventilation between the buildings is nearly zero, and the daylight conditions do not even have daylight penetration for half the unit. With respect to that, 3 parameters were kind of looked at: ventilation, outdoor comfort, and daylight. Comfort was looked at since the current SRA buildings do not have outdoor spaces designed for the occupants. Ventilation studies with respect to height variations, lower mass removal, shifting of urban canyons and voids were looked at, and larger urban superblock removals were also looked at. Strategies were narrowed down, and the resultant conclusion was that with respect to the 4-meter canyons, 7 floors of like the bottom floors need to be removed compared to a 12-meter canyon near the road where just the bottom 2 floors need to be removed. These 2 set of rules combined on the urban massing developed a superblock model where the void gets generated at the center, and at an urban scale, that's the void or the public level that gets generated. some design schemes where the central superblock had a market that was designed for, and the other superblocks, although had similar kind of typology, can house different functions, not just for social spaces, but for schools for the kids, market setups, socializing and women empowerment centers, and also covered sheltered spaces for people during afternoon times. Some existing columns were removed in between, and additional support was added to create a relatively more open weave. These are some visuals showing how the same space can be adapted to form different functions. This eventually results in a 25% removal of the density, where 18% of total removal is of residential area, but the newer massing kind of generates twice the open space that's needed. Coming to a building study, since the existing kind of daylight was analyzed, the increased WWR was tested out, and newer layouts were proposed with compact daylight, with compact depths. Coming to like the potential of the central void. The central void is not just used for the ventilation, but it also could potentially be used as a light well. The potential of that void within like the center of the layout and a provision of a secondary window towards the light well suffices the required daylight levels needed for the units. This is a schematic plan showing how the proposed new units are. The central space, because of the compact units, also gives an opportunity for the occupants to have an outdoor space. Coming to like a climate summary, 76% of the outdoor temperature is in comfort. So the mere solution is to open the windows. Coming to like the building fabric, certain walls were kind of the existing building were retained, and a newer fabric was proposed. The use of terracotta tiles was done to have a lower surface temperature, because these slum occupants also use activities that happen to be sitting on the floor. More adaptable facades were used, and cross ventilation and single-sided ventilation scenarios were used for different periods. This resulted in achieving comfort throughout the year. Coming to like a summary and picking like the hottest period, where the outdoor temperature being 34 degree gives a 30 degree temperature within the units and a 29 degree temperature within the common area. And just some visuals of like how the corridors would be used. So during the daytime, the women and the kids are usually the ones that are using the space, compared to the nighttime when the men come back and like there's a lot more activity happening. And how the adaptability of like the same living spaces can be converted during the day, afternoon, and at the nighttime when the kids use it to sleep. Thank you.
Thank you. Thank you very much. These were two very, very interesting proposals. I like the fact that you both deal beyond climate. So there are two very important issues. It's climate change, including the earthquake scenario, plus the flooding, and you dealing with poverty and slums. I think these are two very, very important and contemporary issues. So I think you were very courageous to take this on board. But another thing I wanted to say is that both of you, in addition, tried to include the sense of community and sharing of spaces, and you both looked very much into the way the locals live, and you wanted both to increase and improve their quality of life and their well-being. So I think this was very nicely achieved. The most common thing in your project, I would say, is that both of you really had or dealt with modularity. And modularity sometimes it makes things more affordable, it makes things more structure, but it could also end on repetition and bonus. But you managed to turn things around. So you played, like in case of Berk, you played with the material a lot, with colors and with form, trying always to have a support why you use that, and you managed to provide some creativity in your project. And with you trying really to deal with this very difficult thing, which is people don't have any money to afford heating, cooling, or whatever, and providing these common spaces to improve the quality of life was nicely achieved, and you described it very well. Well, I think I'm going to pass to my colleagues, because we don't want to extend very much. I also like just one thing, the fact that both of you dealt with courtyards and using those to those communal areas. Who wants to yeah, João. Simos, would you like?
No, because I will be very brief. I want to congratulate you for being both well informed and very informative. You seem to know a lot, and you seem to be quite capable of communicating that to us. So thank you very much. It's a very good lesson. I think given the practicality of your approaches, in both cases we have stuff that you've done because you want to improve conditions. You know how to do that. You have analyzed it. You're explaining what will be achieved if your proposals are applied. The only thing we don't know is how much they will cost. Now, again, following your approach, we hypothesize, I would think, that what you're proposing is quite low cost. But how would I know? And so I miss that. And I think that if you have time, you might do some very quick estimation compared to what is being done at this time. Now, Divy used the word adaptive, and I wanted to challenge people today giving presentations with explaining the word, because we have been using it liberally throughout the year, as you all know, but assuming that somehow it explains itself, or that our course in itself makes the definition of this word obvious, but it isn't. And in fact, in most cases, it's not clear what we mean by the adaptive component, whereas reuse is much more straightforward. So adaptive reuse becomes a bit of a question. Not a bad question, I mean, but one that one needs to be clear about. Now, regarding the results, it was quite, Divy's results very good, and Berk's results also very good. But in the summer, the simulated temperatures followed very closely the outdoors. Therefore, your building, the interior, seems to have been coupled strongly. But coupling it with the outdoor, given the temperatures we were looking at between 25 and 30, well, meant that the indoor will be at a higher temperature than it might have been otherwise. Or am I wrong, because this is a timber structure and it would definitely fluctuate with the outdoor? I'm not completely clear how to interpret your result. Maybe you can say something about it. Oh, you've got your microphone.
So in summer, I tried to stabilize the indoor temperature by using recycled concrete panels. And I believe they can achieve even better results if I use nighttime ventilation. To be honest, I tried integrating nighttime ventilation, but in simulations, I didn't really get a significant difference than the other one.
Okay.
But theoretically, I'm expecting better results if I introduce nighttime ventilation for those radiator recycled concrete panels on ceiling and on the floor.
Yeah, I think it's interesting to see this consistency and looking at the challenges on high-density environments, and here in both cases, that's one of the main issues, both in Istanbul and in Mumbai. But there is another thing in common that I think it differs from the previous couple, is the way that you approach and you based in this concept, this vernacular concept. In the case of Istanbul is the sofa, in Mumbai is the corridor, these communal spaces, and understanding that the way in which each square meter of the built environment, the way in which it's used and shared influences the requirements and the performance as well. And I think what shaping your projects was very much to be very careful with every square meter of these spaces, limiting the amount of space for the individual, but at the same time providing this opportunity when this privacy is needed, but trying to maximize, especially in Mumbai, these shared and communal spaces as an environmental strategy that also allows these economies of scale and providing much better environments than the ones that were already in place.
I'm going to be brief as well. I like so much those architectural designs. I think for environmental thesis, you did a great architectural design, which maybe that's what we want. And this is really commendable. My point is similar to what Jorge just mentioned. I noted here how you could even start your explanation of your project from your transitional spaces in both cases. And it's great to see modularity, prefabrication, with a quite good range of variations in terms of space, or building components like we see in this picture, where when the windows and the louvers open and close. And this is what brings quality. So the numbers, you almost don't need them. It's so convincing, the whole plan and the atmosphere you are creating. And of course, we want to see them, and they are working. But there is a quality there that talks for itself when we look at images like that. And yeah, it's very good to see, encouraging to see how you solve the domestic issues of compactness by actually going beyond the limit of the unit, using those transitional and semi-open spaces. So it's great news for architecture that we can create better environmental buildings by playing with architectural components, and the numbers will be good anyway. So congratulations, guys. Yeah.